Welcome back to Math with Ms. Reimer. Today we're looking at section 4.6, which is constructing functions. And you can see I've been joined by some of Stanley and the royal family, just for fun. A couple things that you need to keep in mind when we're constructing functions is, again, things that you already know. Most of this should be pretty familiar to you. When we're working with an equation, y equals mx plus b, m is the slope or the rate of change, b is the y-intercept or the initial value. If you're looking at a graph, you're looking for the rise over run, or up and down and then off to the right. And if you're in a table, you're looking for the change in y over the change in x, or your slope formula, which is y1 over y2 over x1 minus x2. The y's are always on the top, the x's are always on the bottom. If a question's asking you for the slope, it might ask you for the rate of change, it might ask you for the something per something else, like the cost per minute or the gallons per second or something like that. If it's looking for the y-intercept, it'll probably ask you for the initial amount or for the starting amount. So, in question 1, the Pep Club rented a shave ice machine to sell shaved ice as a fundraiser. They paid an initial fee and then an hourly charge. The table shows the cost per hour. Find and interpret the rate of change and the initial value. Assume that the two quantities are linear. When we're looking from a table, there's a couple different ways that we can do this. One is we can use our slope formula. We have x1, y1, x2, y2. And then we could plug these numbers into our formula and go from there. Another thing that we can do is look and see if the table has a pattern. Well, in this case, on the x's, I'm adding 1 every time to get to my next number. My y's, I'm adding 5 to get to each number. These numbers on the top and the bottom are the change in y and the change in x. Well, we know from up here that our slope is always the change in y over the change in x, so my change in y is 5, whereas my change in x is 1. So my rate of change is just 5. You also want the initial value. Well, we could do this a couple different ways to find the initial value. One of them is to take, if I were to add in some boxes here, well, if I need to go down 1 to get the number of hours, that means I'm going to have to use the opposite of this pattern, and I'll subtract 5, and I would get 25. If I go 1 farther, go down 1 more, I have to do the opposite of this pattern, subtract 5 again. That would mean that the cost would be $20 at 0. Remember that wherever x equals 0, the y value is the y-intercept. The other way that we can do this is to actually write an equation. So we've talked a lot about using y equals mx plus b to find things. So I work off of the equation y equals mx plus b, and I know my m is 5, and I know x and y pairs from my table. For instance, I could use 230, just the first one given to me in my table. And so I could plug in the 30 for y, the 5 for m, the 2 for x, and then solve for b. And we will see, as we solve, we should come out with 20 for our b. Just two different ways that you can go about finding it. Once I have these two options, then writing my equation becomes pretty easy. I always write it in y equals mx plus b form. And so I'll have y equals 5x plus 20. And this represents the cost to borrow the ice machine. In number 2, we look at gardening. Simone planted a tomato plant and measured its height weekly. The total height 2, 3, 4, 5 weeks, respectively. So I'm going to go ahead and stick those in my table here. Were 13, 16, 19, and 22 inches long, or tall rather. How tall was the tomato plant when it was planted? And we're going to assume this relationship is linear. So first, let's look at our rate of change. So if we look in our table, we can see some patterns. In the x values, every time I'm adding 1 to get to my next number. Whereas in the y values, every time I'm adding 3. Now we know that in our slope, we always get our change in y over our change in x. So in that case, we end up with a slope of 3 over 1. So that becomes our rate of change. When we're looking for how tall it was when it was planted, that means we're looking for the initial value or the y-intercept. A couple different ways that I could find that. One is I could use the patterns I see and push my table to go backwards. Well, if I go back to week 1, that means I'm going to have to go back 3. If I go back to 0, go back 3 again, and I get 7. We know that the initial value or the y-intercept always comes where x equals 0 in a table. So we can tell that our initial value is 7. One of the other ways that we could have done this was to take our rate of change and plug it into our slope as well as one of our x's and y's. So I could put in 13 for y, m for 3 for my rate of change, and then 2 for x. So I was using the point 213, which is where my x and my y came from. And then we get 6 on both sides. Sorry, not on both sides, but when we subtract it from both sides, then we end up with 7 equals b. To write an equation for this, we could get y equals our rate of change is 3, plus the plant was originally 7 inches tall when she first bought it, and it grows 3 inches every week. So when we have to explain our rate of change, we're growing 3 inches per week, and the plant started 7 inches tall. And number 3, at the movies, Marcus is a member of the theater club. He pays a monthly fee, and his movie tickets are $5 for an unlimited number of movies that month. The graph shows the cost for each month. Find the monthly fee. So, as we go about this, we first need to find our rate of change. So, when we go to find our rate of change, we can look between our two pieces, and right here between 12 and 17, I can see that I get a plus 5 in my y's. From 17 to 12, same thing, kind of pretending like this is a table without it actually being a table. In my x's, I'm adding 1 each time. So we know our rate of change is always x over y, so in this case we get 5 over 1. And that's because he's paying $5 per month for an unlimited number of movies. And then the initial value, if I were to continue my graph, I can see that it should fall somewhere in between 6 and 9 if the pattern holds. And I can find that initial value by looking for b. So I use y equals mx plus b. Right here I have an x and a y value, so I can plug those two into my equation. I'll have 1250 for y, m is 5, x is 1, plus b. Can subtract 5 from both sides because 5 times 1 is just 5. And when I do 1250 minus 5, I get $7 equals b. We can tell from our graph, if we were to continue it, that it should have landed somewhere in between 6 and 9. So $7 is a reasonable conclusion. So your equation then is 5x plus 7. So you pay $7 initially, and then after that you pay $5 per month to get into the movies. And number 4, for photos, the cost of having photos taken includes a sitting fee and $12 for each portrait. So we already know $12 for each portrait. That's our rate of change. We're looking then for our initial value, or in this case, the sitting fee. The cost of 3, 6, and 9 photos is $51, $87, and $123 respectively. So that means that here, this is the number of photos, and then this is the cost. Again, always x, and then y in our tables. And we're trying to figure out the sitting fee. So a couple different ways we could solve this. One is just by looking at the table and continuing patterns. So we see that in our x's we're adding 3, but in our y's, every time I am adding 36, it seems. So we get 36 between these two, 87 and 123. Again, we get 36. So what that means is my x over y for my slope is 36 over 3, which simplifies to 12, which we already know that it's $12 per portrait. But let's say I try and continue my table. Well, if I'm going to jump, I was going up 3, so my opposite is to go down 3. That would give me at 0. And then if my opposite is to add 36, if I subtract 36 from 51, I'm left with 15. So at 0 photos, it costs $15. Well, that is my sitting fee. The other way you could solve this is algebraically. So you could use y equals mx plus b, and I could pick an xy pair from my table. So I'll use 3 and 51, and then your rate of change at 12. And when I subtract 36 from both sides, 12 times 3 is 36, so I'm just shortcutting a bit. We get 15 equals b. So that's another way to algebraically prove what I'm looking for. When I go to write my equation, I'll have y equals $12 per portrait plus the $15 sitting fee. On the back, The graph shows the distance Jeffrey is from the water fountain after a certain amount of time. Find and interpret the rate of change and the initial value. So in this graph, we can see that if we keep going, we can actually figure out exactly where our y-intercept is because it will end up being at 2. When we look at our slope in this graph, we can see that every time I'm going up 2 because of my scale and I'm going over 1. So my rate of change here is 2 as well. From that, I can go ahead and write my equation of 2x plus 2 after time and then based on distance. And that's just from interpreting the graph without actually having to do any major algebra. In number 2, the graph shows the total cost for a lawn mowing service to mow a lawn. We need to find the rate of change and we need to find the initial value. Now in this one, we can continue our graph and we can see that our rate of change should be somewhere around 20, but because this graph is counting by 10, we need to actually do some algebra to see what we can find here. So I'm going to go ahead and start by just making myself a little table just so that I can do some observation of my pattern here. That might save me some algebra. So when I look here, I've got my x and my y points. I just took these ordered pairs and put them in a table. And in my x's, I can see that my pattern is to add 1 each time. And in my y's, my pattern is to add 8 each time. I know that my slope is always y over x, the change in y over the change in x. So the change in y is 8 and the change in x is 1. So that means that my slope is 8. In this case, that means for every 1 hour, it costs $8. So we're looking at $8 per hour in order to pay for the lawn mowing service. The way we can figure out what this means is if I look back here, I see that this was $8, the y is in cost, whereas the x was in hours. So we can see $8 for 1 hour. So it's really just writing this fraction in English instead of in algebra. If I'm looking for my initial value, I can use y equals mx plus b as we've been doing. I can use one of my points of 128, which will give me an x and a y. I have a slope of 8, and so then plug those in, and then I can subtract 8 from both sides, and we get 20 equals b. So actually, our prediction from the graph is spot on that at $20, you have to pay the initial fee of $20, and then you pay $8 per hour from there. As an equation, you're looking at 8x plus 20 when we plug in our m rate of change and our b initial value. In number 3, in order to enter the state fair, there's an admission cost. Each game is $3, and Stephen went to the state fair, played 4 games, and spent a total of $20 on admission and games. We're going to assume the relationship is linear, and we're going to look for the rate of change for the initial value, and then actually write an equation for it. So we know that each game is $3. That's going to be my rate of change because depending on how many games I play, depends on how many times I have to pay the $3. Now I also have an example. I know that Stephen went to the fair and played 4 games and spent a total of $20 on admission. Well, that together will be an example, which I'll write as an ordered pair or an x and a y. To then find the initial game, to find the initial value, I can plug into my formula. For y, I'm at 20, my rate of change is 3, and I played 4 games total. Do some algebra, and you will end up with $8 for your initial value. So what this means is that we're paying $3 per game, and then it's an $8 entry fee. When I go to write my equation, I'm looking at 3x plus 8. You could have figured this out with a little bit of logic. If you know he played 4 games and they're each $3, well, 4 times 3 is $12. So of the $20 that he spent total, you know 12 of those dollars were on games, so you could subtract that and get your B. Basically, it's a way to logic out the equation that I just did here. In number 4, after writing part of his novel, Thomas is now writing 16 pages per week. After 4 weeks, he's written 85 pages, and assume that the relationship is linear. So when I'm looking at the rate of change, there's 16 pages per week. Remember how we talked about per often tells us what our slope is. So we're looking at 16 pages per week. And after 4 weeks, there's 85 pages. So that's an example, which will give us an x and a y. We'll go back and plug everything into our formula. Y is 85, whereas m is 16, x is 4. I'm looking for b. 16 times 4 will give me 64. And then I can subtract that from 85. And we will get 21 equals B. So we already had 21 pages completed. And then if we put this together in a formula, we get y equals 16x plus 21. And lastly, number 5 on the back, to perform car maintenance, a mechanic charges for parts and $45 an hour for labor. This right here will be my M, or my rate of change, $45 per hour for labor. The total cost Terry spent for 2 hours of car maintenance was $125. So that will become my example. And then to find our initial value, we can take our M of 45, our X and Y, and plug them all in. So 125 for Y, 45 for M, 2 for X. 45 times 2 is 90, and then subtract that 90 from 125, and we should end up with $35 for our B. So it's a $35 payment just to go in, and then your initial value is $35. So put that together in an equation. Nope. Try $45 per hour. And there should be your final equation. There you go.